Okay, tonight we will discuss about one variable in physics. It's known as acceleration. In this video, we will try to know the formula to get the acceleration and the variables needed to calculate acceleration, and of course, when to tell if the object is accelerating or not, and of course, the unit of our acceleration. Okay, so let's define acceleration. Very basic. It's just the change in velocity over time. Okay, so from that definition, change in velocity over time, it's very obvious that we have velocity and time as our variables to calculate acceleration. Okay, going back to the definition, change in velocity over time. So if there is a change in velocity, there is acceleration. Okay, again, if there's a change in velocity, there's acceleration. Very basic. Again, if the velocity is changing in a specific period of time, the object is accelerating. Example, the car moves from 2 meter per second to 9 meter per second in 10 seconds. So as you can see, from 2 to 9, it's changing from 2 and then speeds up to 9. So therefore, there's a change in velocity. The object is definitely accelerating. Now, if no change in velocity, or let's say constant velocity, not changing at all, it maintains its velocity in a specific period of time. Let's say, for example, 3 meter per second in 10 seconds. Okay, 3 meter per second in 10 seconds. So you can see it's not changing. It's still 3 meter per second until it hits 10 seconds. So this case, no, or the object is not accelerating. Okay, please take note, when we say not accelerating, the object is still moving, but in constant velocity. Because a lot of students will think that if it's not accelerating, the object is not moving. But in reality, it moves in constant velocity. There's no acceleration because going back to the definition, acceleration is change in velocity. Okay, so what are the variables needed in calculating A? A stands for acceleration. Again, A is our symbol for acceleration. And yeah, we will try to find out the symbols of other variables here. Obviously, we have the first variable. As mentioned in the definition of acceleration, we have velocity. Velocity is a vector, meaning to say it needs magnitude and direction. Magnitude in physics, it's just another term for value. Okay, let's say 2 meter per second. This is going to be the magnitude. And since velocity is a vector, therefore it must have direction. Let's say, for example, east. So east is the direction. That's velocity. And the unit of velocity, it's meter per second. That's the unit of velocity. Always remember, meter per second, of course, plus direction. Okay, so I will just erase some of the parts to continue this discussion. Okay, because the screen is very limited. Okay, so let's discuss the other one. We have the first variable, velocity. The second variable is the time. There's no negative time, by the way, so it's always positive. It's always absolute in terms of value. Okay, and time, the unit is in seconds, or that's the symbol. Okay, and yeah, that's the two variables. These are the two variables needed in calculating acceleration. And going back to velocity, my apology. In velocity, since the definition says change in velocity, so how are we going to put that in our equation if we have change in velocity? Let's say, for example, going back to our example here, we have the car moves from 2 to 9 meter per second. So there's a change in velocity. Of course, the object is accelerating. Okay, so of course, if there's a change in velocity, we need to do subtraction in this case. But we will try to know which one is our final velocity and initial velocity. The difference of these two variable, that's the change in velocity. So final velocity, very obvious, it's the end meter per second, or it's the end motion of our observation in specific amount of time, let's say 10 seconds. And initial, from the word itself, initial, it's the beginning, so it's the starting ms, and our final is the ending ms. So from 2 to 9 meter per second, from 2, it begins at 2, so it's our initial. 9 is our final. Okay, so we can get the change in velocity by just subtracting final and initial. So our final is 9 meter per second. This is our final. This is our initial. Copy, minus. And then initial is 2 meter per second. And therefore, our change in velocity, it's 7 meter per second. And there must be direction. So let's say it's east. Okay, so let's try to find out now what's the formula of acceleration. Okay, we will clean the screen first. Always remember, there is only acceleration, or the object is accelerating, when there is a change in velocity. If velocity is constant all throughout the time, of course, the object is not accelerating, but the object is moving in constant velocity. So from that definition of acceleration, we can express it mathematically. So we can have the value, or the variable a, representing the acceleration. It is equal to the change in velocity over time. Okay, so all you have to do is to divide velocity by the time. Okay, the change in velocity, we can write it this way: vf minus vi over time. Okay, so what's the unit of acceleration? We can figure out the unit of acceleration by calculating it using its formula. So acceleration is equal to change in velocity over time. Let's say, for example, the object moves from 2 meter per second to 8 meter per second in just 9 seconds. Okay, so we have time from 2 to 8. So from, it starts from that velocity, so that's going to be the initial, and obviously 8 is the final velocity. Okay, let's use this variable in calculating the acceleration to know what's the unit of acceleration. So it's the change in velocity, final minus initial, over time. What's our final velocity? It's 8, so we will place it here. 8 meter per second minus initial, 2 meter per second, all over time, 9 seconds. 8 minus 8 minus 2, so you have 6 meter per second divided by 9 seconds. In fraction, we should, when dividing fraction, of course, we will have the reciprocal of our denominator, the multiplicative inverse, if I'm not mistaken. So we can say that we can write it this way: 6 meter per second divided by, we will make it, we can make it in multiplication, and let's have the reciprocal of 9. Obviously 9 second, it has over 1 in the denominator there. So if we will get the reciprocal of it, we will just put 1 in the numerator and the 9 in the denominator. So we can have 1 9 seconds, and then we can do the math. Okay, we will multiply numerator and numerator, and then denominator. Since it's a whole number, it's understood that it has 1 over there. Okay, and we can multiply denominator to denominator. So 6 times 1, that's 6 meter, and then 1 second times 9 seconds, so that's 9 seconds times seconds, it will become second squared. So second squared. So we will divide 6 divided by 9, so you will have the answer. You can simplify it. The answer is 0.666 or 0.67, and the unit, observe, meter per second squared. So that's the answer. That's how you will get the acceleration, and the unit of acceleration, it's meter per second squared. Thank you, and I hope you learned something from our short video at this moment. See you in the next video.